Good day everyone, welcome to Bright Engineering. Today we are going to look at limits of a function, and under limits we are going to talk about the continuity of a function. So under continuity, a function is said to be continuous if it is defined under three steps. So first of all, the function has to be defined at a point, and then secondly, the increase and decrease limits of the function has to be the same, and lastly, if the points being defined is equal to the limits of the function, then it means that that function is continuous, right? So let's look at an example and then we would understand what I'm saying better. So first of all, we have our function f of x to be x cubed plus 2x, right? And it is being given at a point which is x is equal to 3, right? So like I said, firstly, it has to be defined at a point. So step 1, we have to define f of x. So x is 3 here, so f of 3 is just going to give us 3 raised to the power 3 plus 2 times 3, and 3 raised to the power 3 is going to give us 27 plus 2 times 3, which is 6, and the answer is going to be 33, right? Step 2, now we have to find the increasing and decreasing limits of the function, right? So limit of f of x, which is x cubed plus 2x, as x is increasing, so the increasing, we have 3 plus here, and should equal or approximately equal to the limit of f of x, which is x cubed plus 2x, as x maps to 3 decreasing, right? So with the increasing and decreasing limits, we just have to attach it with a small and minute number, right? So with the number, we are going to use 0.01 and see how significant is going to affect our limits, right? So here with the increasing, we are going to get 3.001, and with the decreasing, we are going to get 2.999, right? So the limit is going to give us, by direct substitution, we are going to get 3.001 cubed plus 2 times 3.001, and we are saying that this should be approximately equal to this, which is going to give us 2.999 cubed plus 2 times 2.999. So when we punch this on our calculator, this is going to give us 33.029, which is approximately equal to this, which is 32.97, right? So when we run this, we are getting 33, and then when we run this too, we are getting 33. So it means that this is approximately equal to this, right? So we are done with step 2. And for step 3, we just have to compare. So now we compare our f of a, which is the point or the limit, to our limits, right? To the limits of f of x as x map to 3. And this, if this is equal to this, then it means that our function is continuous. And at f of a, or f of 3, we had 33, and our limit is also giving us 33. So it means that this particular question is continuous at x is equal to 3, right? So second example, the second example is different from the first one slightly, because if you don't take care, you might confuse yourself, but then it's not difficult, right? When you look at the second example here, they've already defined the function for us, that as x is equal to 0, our function is going to be 0. So the answer of our function is going to be 0, unlike the first one where we had to insert our points in it to get our answer. Here it has already been defined for us, and here they are telling us that in order for us to use this function, x shouldn't be equal to 2. So it means with the limits where we have to use increasing and decreasing limits, then we have to resort to this particular function because it's either greater than 2 or less than 2. Please, I hope that's understandable. So let's go back to our question. So here we know that f of a, where our a is equal to 2, is equal to 0, right? So this is the first step, which is we just finding a point, or we just finding a value for our function. And then step number 2, we have to find our increasing and decreasing limits, right? So limits of f of x, which is the x squared, because here our x is going to map to 2 plus, which is greater than the 2 like I talked about, and this should be approximately equal to limit of x squared as x mapped to 2 minus, right? Now x, here we are going to get 2.001 squared, and this should be approximately equal to 1.999 squared, right? So this is going to give us 4.004, approximately equal to 3.996. So if you run this, we are getting 4, which is approximately equal to, when you run this to the nearest whole number to, you are getting 4. So we are done with step 2, and then this is also true for the rules that we have to go through. And then lastly, we are saying that for step 3, our f of a should be equal to the limits as x maps to 2 of our function, right? And then for f of a, or for f of x, we had 0, and then our limits, or the limits of our function is giving us 4, right? So it means that 0 is not equal to 4. So henceforth, we can just conclude that our function is not continuous at x is equal to 2. Thank you very much for following us through the end, and if this video is helpful, please don't forget to subscribe, share, comment, and then like.